here at the glass face pump demo to go over another example for you. I call this one wash-a-pose work order. It's definitely one I've seen multiple times in the field, and it's really a good example of how you can take a happy pump and kill it pretty quickly. So again, I've got a pump that theoretically is a very happy pump. I've got a nice clean suction line, no air entrainment, no cavitation. Right now this discharge pressure gauge shows 15 psi, but let's just suppose that's times 10 for this example, 150 psi, like a nice high pressure shower pump with, again, a very happy setup and a nice high 150 psi discharge pressure. So let's use a paper machine example, and it's determined that the operations needs a wash-a-pose header to better clean the machine during sheet breaks or in between grade changes or whatever. So somebody innocently is walking around and maybe sees a nice discharge pressure gauge on this pump that's been happy for years and sees 150 psi. The thought and the good intention here is I have a very nice pressure out of this pump that I would love to give the operations folks to help wash up the machine. They should be able to wash the machine from the operator side all the way to the drive side without interacting with the machine or causing any issues. So a work order is generated, and it's to add a wash-a-pose header off of the discharge side of this pump system to leverage this 150 psi to be able to properly wash the machine. So the down day comes, the work order is executed, and the header is installed, and then the system's started back up, and this could represent after the work order's been executed and the machine's running again. Nobody's using wash-a-poses, so the system is very happy. Everything is just fine. But now we're going to fast forward to the next outage, and this pump that has never been a problem all of a sudden had a seal fail in it. So, okay, put a work order in, and we're going to order a seal, and we're going to go ahead and replace that. So we do that on that work order, and then the next outage comes, and now we got a bearing pickup, or maybe I lost another seal. So it's a little confusing to everybody, because when everybody comes by the pump in its normal operation, everything is fine. But all of a sudden we're starting to have reliability issues more and more frequently. Maybe we, do have the seal provider come in and take a look at the issue to see if there's a better seal that could hold up longer. But really what's happened is we've kind of ignored what the original problem was right from the beginning. Again, all intentions being good, what we've done is we've modified the system intermittently without analyzing the pump itself to see if it can handle it. And I should be able to demonstrate that for you guys. So again, the work order's been executed, the wash-a-pose header's been added, the pump is very happy, there's no signs of a problem. But then let's say 2 in the morning comes and it's the first sheet break or the first grade change, and we need to go ahead and wash up the machine. So the operators grab their brand new wash-a-poses and they start washing up the machine. And I start cavitating almost immediately as soon as I put that extra load on this pump, which was designed for the flow rate and head conditions that were original but not the added wash-a-poses. But then they go ahead and they stop washing up the machine, and then everything's just fine. If the seal had failed in that short instance, somebody might come to the pump to try to figure out why the seal has failed, and everything seems to be happy. So they replace the seal in the next work order. Next several wash-a-pose cycles go on, and this is what we're doing to the pump. Every time we use the wash-a-poses, shaft deflection, mechanical seal failures, bearing loading, possibly even a snap shaft, possibly. But every time we come look at the pump when it's in its normal running condition, we can't really understand what has happened. So this is a perfect example of just not looking at the whole system before we make a system change. And every time we touch a system, we should go back to the beginning and start talking about the things that we talked about at the beginning of the presentation. What are my process conditions? What's my fluid conditions? So that I understand that the pump that's existing is still set up properly for the change to the system downstream of it that I'm making. So that's that example.